अस्सलाम वालेकुम। Georgia M of Britannia. Let's see. Yeah, no, just K56.
Alright guys, Assalamu alaikum. Okay, so let's just do a quick revision. What are some of the things that you have learned yesterday? IP address. How many different type of IP addresses do we have?
2.
IP addresses. Okay. And what is the first one?
IPv4.
IPv4. And can you tell me a little bit about this?
It's the earlier version.
Okay.
developed
And
in the 70s.
okay. And
It only has 4.2 billion.
okay. So limitation is 4.2 billion IPs. What else? 4 octets. Yeah. The numbers fall anywhere between here and here. Right?
Yes.
What else?
3 classes.
Industry standard is we have class A. Class A has a limitation of 16 million IPs per network. And usually this starts with $10. And then class B, and what is the limitation? 65K IPs per network. And this starts with
170.
172 dot. And then
Class C plus
class C. And this has
250.
255 IPs. And this is per network. And this starts with 192. There is class D and class E also. But one more thing that you have to keep in mind is any address that starts with 127 is a loop back address. Loop back address. Now what does the loop back address means? What that means is if you have a laptop and you want to connect somewhere, but this using 127, it loops back to itself. Okay, so any address with 127 is basically just the loop back, so it is coming back to its own address. What else? Now we have IP. What's the other one? IPv6 version 6, and then what about IPv6?
It has 8 octets.
8 octets, okay. And can I say this is alphanumeric?
Yes.
Yeah, so it starts anything from 0 to 9 and
8F.
A to F, and this is called hexadecimal. And how many IPs do we have in here? 8 billion people on the planet now, times 50,000. Whatever that number is what? How much? So if you calculate this, 8 times 50 is 400,000. 400. What is that? 400,000 billion IP addresses. Yeah, this is a rough estimate, and what they are saying is even if you have this much, you will still have a lot of IPs that are left. What are the other things? Come on guys, we learned a lot of things, right? What are the other keywords that we have learned?
WAN,
Network.
LAN.
Okay, so network, when we are talking about the network, we are using the command prompt. From the command prompt, I am getting config, IP config, which will give me the IP address, subnet mask, and default gateway. Default gateway. IP address and then subnet mask is either 255.000. This is class A. If I have 255.255.0.0, then this is class B. And then if I have 255.255.255.0, this is class C network. Now default gateway is always your router's IP. Router's IP address. So for example, if my IP address is 192.168.2.171, my router's IP is 192.168.2. 192.168.2. What is the router's IP address? It reserves one IP for itself. 1. Okay. Now if you say IP config, instead of IP config, if I type IP config /all, it is not only going to show all this, it will also show you physical name. Now physical name is also considered as MAC address. This is the unique identifier. This will never change. MAC address will not change. Computer name can change. IP address can change. So think of this as your SSS number. Whereas this computer name is just a name, it can change. IP address is just a phone number and it can change as well. Okay? What else?
Intranet, internet.
Sorry?
Intranet.
Okay? So now with the networks, we also have LAN and we have the
WAN.
WAN. LAN is something that you can control. Here, do not have control. Anything else? LAN is also considered as intranet. And here, this is internet. This is sometimes called inside network, whereas this is outside network. Regardless, depending on which author that you are reading or which article you are reading, they can use some of these words. Yeah? What else?
Static IP.
Static IP. So every router has DHCP and it has the static IPs. DHCP is router control. Router control, the distribution of IPs. Distribution of IPs. Whereas the static IP, the network admin control the distribution of IPs. Yeah? Now with the DHCP this is also called the dynamic IPs. There is a lease time. Here, these are the, when I say static, these are good for what? When do we assign the static IP?
The servers or the
Machine.
Yeah, these are good for servers, where we don't want the IPs to be changed. And DHCP is good for
Host protocol.
clients, laptops, etc. Right? What else?
Static is 2 to 50.
We can define that. So depending on your network admin, they may say we only have 20 IPs that need to be static. So they will decide from 1 to 20. And then everything else router can manage. So depending on what your network is doing. So let's say if your network admin decide that we have 100 machines. So from 1 to 100 it will keep as static. Everything starting from 101 to 254 is what?
Dynamic.
Dynamic IPs. We also have a switch. Switch is what? An extension to
An extra.
router. Yeah. So switch usually comes in different configuration, 4 port, 16 port or 8 port. We have 16 port, 24, 32, but I have also seen 24 and 32 port and 64 port. And I have even seen that 128 ports also. Depending on how big of a network that you want. Anything else? That's all we learned?
NAT.
Okay. Router uses, so here if you have the router, it uses the NAT, network area transition. What exactly does it do? So if you have an IP that was given to you from your ISP 9876, it is going to convert using the NAT to 192 address, 192, 168, 1 dot, and then it can start, one is router's IP and then 255 is the broadcast. And this is router. So that means we have the limit of up to 253 under the same network of 192.168.1, which is outside network. Here is the WAN and here is the LAN network. Anything else? Now, I'm going to ask you a simple question. let's say if there is only one computer on the entire planet, what is the IP of that computer is going to be? If there is only one computer on the planet, the whole world, what is the IP address of that computer? One. But remember, the minimum requirement is you should have 4 octets.
255, 255, 255.
Why 255?
That's the basic.
This is the one.
You are talking about the subnet. Here I'm talking about what is the IP address of that computer going to be. Now I can, for sure, I can say that it is going to have the 1. But what about the leading octets?
0, 0, 255.
0, 0? Okay. So can I have 0, 0, 0? Remember the first octet, the minimum number is 1. So if I have only one computer, why even go with something like this? We'll just have some identifier saying 1. But then you may have 20 other computers that you want to join the network. To join the network, then we will say, okay, if we are talking about networking, if it is only one solo computer, I'm just going to give it I don't even have to network because it is not connecting to anything. We can just name it as 1. But if I have 20 more computers that are they are all connected to each other, we want to have the connection. So I know the first computer I'm going to have is 1. And because this is the first network, I'm going to say the first network is 1. So maybe I will just say 0, 0, 1. And then this is also 0, 0, 1. Now with the first network, now leading zeros we don't usually put anything in here. So I will say my first network will start with 1 and then it is going to end with 1. But the network is this. This network can have from 1 and then it can go up to 255. But what about the leading octets? So the first octet I picked is 1 because I cannot start anything with 0. What about the second octet and third octet?
0, 0.
Why do you say 0, 0?
Because it goes from 0 to 255.
Well, that's what I said yesterday, but I want you to think about this. Why 0? Why not 1? If this is the first network, I will just say 1, 0, 0. So 1, what is the minimum number? Is it 1, 0, 0? What is the lowest minimum number of 3 digit? 1, 0, 0 or 1, 1, 1? What is the lowest number of 3 digit?
1.
1, 0, 0 or 1, 1, 1?
1, 0, 0.
1, 0, 0. So can I say the lowest number network, I'm going to start with this. And then once this is done, then maybe I will start with something like this. Can I erase this now?
Yes.
If I said 1, 0, 0, 1, my first network of the minimum digit, minimum 3-digit number, okay, and then 1. So here I'm going to start with 1 and then I'm going to go with 255. Once I'm done with this, what is the, if I need more computers, what is the next IP that is in the list now? 1, 0, 1, 1. Can I say that?
Yes.
And then this is going to grow from 1 to 255. Then the next IP would be 1, 0, 2, 1. And it will start from 1 and 255. and at some point it will reach at 1, 0, 255, 1, and then here the same. What is the number after this one then? So once we reach this one, what do we have the next IP? 1 dot, 1 dot, then again we have the 0, right? Because now 11 network is there, and then 1 here again, the whole series starts. So the first number is 1 and then the last number is 1, but the octet of the minimum octets that we are seeing in the second and the third is always going to be 0. That's the minimum. Okay? For simplicity's sake, yesterday I said that let's just keep 1, 1, 1, 1, but in reality this is how it is going to grow. You okay so far? Now I'm going to play let's say we are doing some banking with one of the bank. Okay? So we'll start with the whole process of how does everything go from your machine to the your bank and get the information back, and what happens during the entire process. I'm going to erase this now. And Zaid, you have to be on time from tomorrow or from next class, okay? So this is where your machine is. You say this is your intranet. This is your home. Everything from here is your home. So you have your laptop. Your laptop is connected to a router. And your router has 4 ports and it has a WAN port. This WAN port is connected to your home network or to your port that is connecting outside. Okay. So the IP address that is given to you by your ISP is, let's say, 9.8.7.6, and internally it is converted to, you're using NAT, router is using NAT, and it is converting this IP into an IP of 192.168.1.1. That means now it has given this machine 1.2. So 192.168.1.2. The network here is this one. Are we okay so far? Yeah? Now you said, as a customer, you said, I want to go, you want to open a browser, so you just open Chrome. And then you said, I want to go and do banking with bank.com. Now, as soon as you say bank.com, what exactly happens? You open up the Chrome, and then the Chrome said, where do you want to go visit? And you said, I want to go to my bank, which is the URL is the bank.com. And you just press the enter key. Can someone explain to me what happens when this happens? And let's say you have this client A, and then maybe there is another Wi-Fi client sitting here somewhere. Maybe your brother is working on it, and then there is another machine which is your media server. So this one is .3 and this one is .100. Same network, the clients are getting the DSCP, and here you have the static. Now explain me, as soon as you hit enter, what is it going to happen?
It's going to go to bank.com.
That's what you want, but technically what is happening when you hit the enter? Now, as soon as you hit anything with the HTTP, so usually it starts with either HTTP or HTTPS, Hypertext Transfer Protocol or Hypertext Transfer Protocol with the security. Now, depending on which one you are using, most of the financial institution, okay, they will use a security encryption, and that's why you use the S at the end, HTTPS. Now, as soon as you say bank.com with just the HTTP, basically what you are doing is, this is same thing as how you are saying is, go to bank.com on port 83. Port 80. Now, what exactly this means here? Now, have you ever entered any port number when you go to any website? By default, every time you are using the HTTP without S, basically what you are saying is, go to this home and knock at this door. Go through this door on the server. If you are using HTTPS, yeah, so now you are going to the same home but through a different port, and this port is 443. It's hidden. It will never show you. But in reality, if you look at the coding in the background, if you are using HTTPS URL, you are actually knocking at this door. So here you are saying, go to this home and go to this door. Go knock this door. Okay. Now, in reality, whenever we say the doors, in a computer language, the doors are nothing but the ports. Now, how many different ports do we have? Number of ports on each computer. On each computer. Do you know how many? Afia, do you know how many ports do we have? 65,000 ports. This number, obviously it starts with 1 and then it ends with 65,000, around 65,000. Now, majority of the companies has dedicated one port for themselves. For example, browser always use either port 80 or port 443 is common, any of the websites. Then port 22 here also has, this is called SSH port. This is common all around the world. Secure shell. SSH means secure shell. When we go into the Unix, we will look into this. Then we also have another one, which is, for example, 1521. 1521 is Oracle basically said, everywhere, wherever the Oracle is being used, to get inside the database, we will always use 1521 as the Oracle's default port. Remember, two ports that we are going to work extensively is SSH and 1521 in our database administration class. Now, port 22 is to get inside of Unix server. This is to get inside of database. Which database? Oracle database. We will be using this in our entire class. And then there are a bunch of ports. IBM has its own port, Microsoft has its own port, database server has its own port, web servers, and then, now these are the default ones. Can you change it to non-default? Yes, you can. You have the complete authority. But in general, the industry, all these industries came up with this list and they say, we are going to start looking into each of these ports here. Okay? Now, if you just Google search for ports and the owners of the ports or something like port list, Windows port list or Unix port list, you will get a Wikipedia page where it defines you all the way from what are some of the most common ports that companies are using. Now, as soon as you do this, basically what you are saying is, you hit enter, this enter is changed to port 80 if you are using HTTP. So let's say we are using port 80. So here, what it will do is, it will open up two ports, two packets, and these are called the network packets. So here we have the network packet. Okay, so I'm just going to say one packet for now to keep our simplicity, right? So one packet basically says, we want to go to bank.com and knock at the door port 80. Let's say, whatever the mechanism, let's think of that as an envelope. This envelope has only two information, where to go to and which door to knock to. So can I say this is the destination information? Yeah? This envelope is now inside another envelope, another layer. This layer is your source layer. Because if I have to go to the destination, I have to pick up the information and then bring it back. So now I need to also know what is the source it is going to go to. So for the source, it is going to give all this information. What information? What is the host name? Is this? What is the IP address? It is this. The IP address can change. Host name can change. So it will also have the MAC address. MAC address, which is the physical address. Source, IP, and then the MAC address. But remember, you have 65,000 ports. These are the ports that are to get in. To get out, there are ports also, which is going through from here. Among the 65,000, we have some ports that are in, that are some of the ones are out. It is also going to have the source that it is using to go out. The way it is has the to get in, it will also have the port that it has traveled to. So let's say 28,751 is the port. So host name is Scott PC. IP address, internal IP address is 192.168.2. What is that? Or 1.2. Now this is the internal IP. What about the external IP? External IP is the IP that is given to the user by your ISP. So that is 9876.9.8.7.6. Now with this information, does it have enough data to carry? One is where to go to the source and which port to knock. And then on the way back, it has the internal IP and external IP, which port it has used, yeah, which computer it has used, what is the MAC address of that computer, so F398, blah blah blah, all this information. Now imagine you are just saying, I want to go to bank.com. The user has just entered this, not even the www. So user has entered 1, 2, 3, 4, 5, 6, 7, 8 bytes. 8 bytes has converted to how many bytes now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the different bytes. So now your packet started out with 4 bytes After this whole wrapping in the envelopes, it has become about, let's say, 150 bytes. Yeah, it started out with a very tiny packet, but this tiny packet has given the information about the source also. Then this packet leaves from the port 28751 and it is keep moving, moving, moving. At some point it hits the router. Yeah, this is happening so fast we don't even realize it. As soon as you type in bank.com, your website opens up in 1 or 2 seconds. But in those 1-2 seconds, all this are happening now. So at this point, it hits the router. The very first thing router says is, hey, how many computers do I have connected? This is the source computer, but I have one computer here. I have the second computer here. Yeah? So let me ask if any of these guys are bank.com. Hey, it's broadcasting the message. Are you bank.com? This guy is not going to reply. Yeah? So it broadcasted the message and this guy just keeps quiet. What about this guy here? Are you bank.com? No. So immediately, router has to forward this information to the next layer. So the packets started traveling now. New packet or this packet is now wrapped with another packet. This packet has the router's info now. And then it puts some of its data in here. Then this router has forwarded this to the next layer. As soon as the next layer, wherever that port is, and it is going forward, 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 and then it has, your ISP has multiple connectivities between before it reaches the ISP. Okay, maybe there is a switch here. Maybe there is another router here. Maybe there is another switch here. Yeah? So your packets are keep traveling, 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 traveling. Are you guys bank.com? Obviously, if it is switches, it won't even ask. It will just keep going forward. But every forward here, let's think of this as a train. Your train leaves from here, but it has train stations between before it goes to the destination. In technical term, these are called hop. So how many hops do you have here? So the source is started from here, the first hop, the second hop, the third hop, fourth hop, fifth hop, and then finally it reaches the ISP. 6 hops so far. Each hop is adding its own layer. Because the way that it is going, it has to come back the same way. So your packet is keep increasing. So now I have 6 hops in between. Yeah? So 1, 2, 3, 4, you have another hop here. Each hop is giving its own information. So the packet that is started with 4 bytes, now it has maybe 900 bytes. Or let's just keep it simple, let's say 400 bytes. So the packet has started. Now, the way that it is adding layers, on the way back it has to remove the layers to go to the next layer. We will talk about that. Now, among all of these guys, nobody has said, I am bank.com. So it goes to ISP, the ISP that the internet service whoever is providing. And finally it reaches there and it says, hey, who is the bank.com? I have to go to this. Yeah. Your ISP says, wait a minute. I have 4 computers that keeps the information about the name, the website name, and then the website address, IP address. So what it will do is, it will say, I'm going to forward your connection to my next layer. This layer is called the DNS server, domain naming server. And usually, because it is a big company, it is not just going to rely on one server. So the same copy of the server, they have multiple copies of the same server. So I have the DNS server 1, DNS server 2, DNS server 3, and DNS server 4. DNS here stands for domain naming server. Okay, so think of that as a spreadsheet. This spreadsheet is basically keeping about the IP, the name, domain name, and domain IP address. So for example, it has Google. Google.com resolved to 17.14.93.81. Microsoft.com. It resolves to 9.17.43.171. Bank.com. It resolves to 4.5.6.7. Immediately now it knows which server I have to go from the DNS server. So the DNS server are so important that unless your unless your computer knows which IP to go to, it cannot resolve. If you have to communicate with Mohit, there are so many Mohits in the world. But if you also give a phone number, then they not only know that you are going to the right Mohit, but they are also getting the right person. Right data is being communicated. So every domain name, if I register my domain, mohit.com, it will have a IP that is given to it. So all these IPs are saved here. So now our Comcast guy here have that, I know that they have at least 4 DNS servers. The first DNS server that they are using is 8888. The second DNS server is 888.9 or something like that, right? And then they have the third, and then they have the fourth. So pretty much everyone who is using Xfinity or Comcast, if they cannot resolve the name, they are being redirected to their DNS servers. Does that make sense? This is how, if your router cannot resolve the name with this IP, then it forwards to the next connection. Next connection forwards to the next one, every hop, and finally it reaches the ISP. The ISP door that it knocks and it says, hey, I'm looking for the address of this guy. So it redirects it to the DNS server. Now depending on which server is busy, how much, it may redirect to 1, to 2, or to 3, or to 4. Depending on which server is doing how much workload, it will redirect to you. And then finally, one of that hits the IP address and it says, oh, bank.com is 4.5.6.7. So you got this hit, it says 4.5.6.7 is the guy that you want to go to. Is it pretty simple now? But before I get into this, how big of a packet that is started from 4 bytes, but then it has increased, and now the ISP, it may add its own layer in here, so now I have 450 bytes. Your packet is getting fatter and fatter. So finally, it says, okay, I am going to the internet. Okay? Now assume for a second that this bank.com is, let's say you put chinabank.com. Now chinabank.com, you may be one of the rare websites that are not hosted in US, and that your DNS server does not know, none of these entries are made in here. So now obviously it will say, I don't know which IP. Instead of getting to this one, it says, I do not know which IP bank.com is, but I do like to know which one is chinabank.com. So now it is keeping a slot open for itself. But then it forwards that to the next layer. The next layer is, it has opened up to ask the internet. Now it is hoping that somebody would say, what is the IP address of chinabank.com? Now it is asking the internet. Now internet obviously has DNS from US, DNS from UAE, DNS from India, DNS from Australia, DNS from China. So what it is hoping is, it is going to look for broadcasting the message, hey, among all the DNS servers in the world from every country that is maintaining, does anyone know what is chinabank.com? Now, among all the servers, whoever has the information, they will reply, otherwise they will sit quiet. So finally, you get a reply that it is 4.5.6.7. Now remember, your router, if it has the information, you get a reply of 4.5.6.7 immediately. If it does not, then it sends among all the hops, your packet is getting fatter, and it will send that to the ISP. ISP will look into the local DNS. Can I say this is the local? So this is your router is actually also represented as a local DNS server. Then you have the ISP DNS server. So here you have the ISP DNS. And then if you cannot find that in the ISP DNS, then you have the internet DNS. The whole goal is to find what is the domain name IP address. And finally, it finds the IP address. Now, among all of these, this is another hop, this is another hop, this may be another hop, this may be another hop, this is redirecting to this one, this is redirecting to this one. So among all of these, your packet is getting fatter and fatter and fatter. So by this time, it may be about 800 bytes. Although I don't think it will be that big, but I'm just giving you the information. So finally, it finds the IP address. Hooray, right? We finally found the IP. Now how long is it taking to find all this? Less than a second. That's a pretty fast speed. So we have to come back and we have to see how exactly we are getting this kind of a speed. Yeah, this China.com is on the other side of the globe. How are we getting the information that is put here in Palace Park all the way to China and then get the reply back saying that this is the IP address, and we don't even notice. We hit the enter key and in 1 to 2 seconds we have the website open. This is all happening in the background at the micro nano speed. So we have to also come back and ask ourselves why things are so fast in the computing world. That's why the technology is taking over. So we'll talk about that, why it is so fast. But at this point, it finally finds the IP address of chinabank.com. So finally, one success here. Yes? Can I erase that side? our packet, which is more fat now. Right? So now from here you are routing to the nearest point. So let's say if this is somewhere on the other side, so now it finally finds that particular site, and because of all these different routes, so right, we have different hops now. So your packet that started with this one, it is actually grown pretty fat by this time. So you finally hit, so this part is intranet of your home, this is internet, and again we got into the intranet of chinabank.com. Right? Because that is their internal network. So this is our home network, this is the internet, and then we have the intranet of this company. So the very first thing the company is saying is it has something called a firewall. Okay? So now you got inside in here, but remember, what door is this? Because the computer has different doors, right? So now you are inside, you hit the final intranet, their router site, but you are asking, hey, I want to go to this one on this particular port. So it may have hundreds of ports in here. It is going to hit knock the door at port 80. Port 80 says, because you came to me, I'm going to send you to the next layer. The next layer is the firewall layer. Okay? Firewall, it's going to grill its own way and finding out if this is a genuine packet or no. Now what do I mean by genuine packet? Have you ever heard about SQL injection? For people who don't know what SQL injection is, basically when your packets are traveling, look at this traveling from all the way from Chicago to China, and it has multiple hops in between. While the packet is traveling to this one, your neighbor has injected something in here. Imagine that. So on this destination, remember the packet has the source and destination? Destination, it says go to 4.5.6.7 and the source is 9.8.7.6. Yeah? Your neighbor who is at 9.8.7.5, they inject something in here and they change that to 5. Imagine that. So on its way back, it is actually giving the banking information not to the original guy, but now it is giving that to this guy. Can that be a problem?
Yes.
A big problem, right? So here, one of the things that your firewall is doing is, are you sure that this packet is all clean, nothing injected, nothing changed in between, all the hash values are good, all these different things are good? It says, yeah. If it finds that something has been injected, then immediately it stops right here, and then the user is getting bad signal, right? The website cannot be found, or reload or something. The error. If nobody, so now it continues the same route. But this time, so let's say this is the first time it happened, the error. Yeah? But do you think on the way back, it knows where the destination is? So ChinaBank.com is somewhere here. So it is going to get updated in my local ISP. So now it has ChinaBank.com. It is going to record for next time. If somebody asks, it has to be pretty fast. So it records that, and then it comes back. On the way back, it is updating your router also. Hey, if the user executes the ChinaBank.com, immediately, don't send it to everyone else. Immediately, now you know it is 4.5.6.7. Now the user gets the message saying that the website cannot be loaded. The user tries again. I'm going to try this again one more time. This time, it is waiting. But do you think this time is going to be little faster than the last time? Or much faster than the last time?
Yes.
Why?
The router already knows.
The router already knows the IP address. So it doesn't have to go and ask the ISP, it doesn't have to go and update the DNS. It is simply going to get the closest possible to the internet. And it already knows where to go. So this time it has bypassed some of the lengthy paths now. Why do I have to go to the ISP when I already know? So I'm just going through the internet to get to the location. This time is much quicker from the last time because everything is cached. The IP address of that host is cached, and since it knows the IP address now, it can go pretty fast. It doesn't have to go through all the different hops now. And finally, the firewall says, all right, this time you came clean, no injections. You simply bypass this guy here from a different route. So now it says, okay, I'm going to let you in. Now the firewall does some more things, and firewall says, okay, I'm going to go to a different, I'm going to forward it to a different layer. However, this ChinaBank.com has so many different users, the firewall is getting very tight in scanning. So now the user will have to wait. User waits 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, and he is still waiting. Why? Because the firewall cannot process this information in real time. Why? Because there are 100 other users waiting, so it has to process first in, first out, first in, first out. So to tackle that, some companies may have multiple firewalls. Firewall 1, firewall 2, firewall 3. So depending on the admin who is working this, they may have something called a round robin fashion. Whoever comes in first, go to the first one. Whoever comes into the second, go to the second server. Whoever comes in third, go to the third server. And then this is how, instead of workload is being balanced by one system, now the workload is balanced by 3 systems, or 4 systems, or 5 systems. Does that make sense? And then they are all working together. Now, this firewall, the industry standard firewall, comes from Cisco, a company called Cisco. They are giants, the way that Oracle is a giant in Oracle in databases. Cisco is the giant for any of the networking gadgets. Firewall is one of their security. So here, Cisco, so the guys who are maintaining this machine is called the security admin. Okay, or the network admin. We'll talk about that later on as well. Now, security admins / network admins. Okay. And it uses the round robin fashion. So connections are round robin. Using first in, first out method. This is firewall 1, this is firewall 2, and this is firewall 3. Okay. Now the work of the firewall is just look into the scan the packet. Once the packet is scanned, and depending on which server, so let's say you hit this server in this, your connection, your packets, so your packets travel this route, and then from here it goes into the second one. From here, now it says, hey, bank.com, do I still get the home page? No, because you have not reached the next layer yet. Firewall is just scanning for the right packet, and then it forwards to a next layer. This next layer is called web server. Web server. Okay. Web server is nothing but the one that hosts the website. Hosts the website. The front page of the website, which is, let's say, the home page, is called index.html. Index.html, hypertext markup language. So your home page is nothing but a coding of page. The name of that page is called the index.html. So if you go to any website, Google website has a very simple index. It just has one box, it says Google, blah, 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 that's it. If you go to ESPN.com, for example, the home page has a lot of other graphics, the sports, the current news, and it constantly being updated based on the results of the teams. So the index.com, index.html is the front page of your website. Now, if you click on the next, if you click somewhere, then it has the other page. If you click something else, it has the other page. If you click something else, it has the other page. So your pages are getting rerouted from the index.html. Okay. Now, obviously, this server, the web server also has some capacity. Maybe it can only serve 1,000 users at any given time. For most of the companies, this is pretty simple. Imagine how many web servers you need for, how many users you have for Google.com at any given time. Could it be more than 1,000? Definitely. Maybe in millions. Yeah? So maybe one web server is not capable of doing that. Then they will put another web server. The same copy here, the way we have the firewall, which is the same copy. Yeah? So now one web server, maybe there is another web server. Some companies has more web servers. For example, Google may have hundreds of web servers. Whereas if you go to Macy's.com, it may have only 4 or 5 web servers. If you go to any other insurance company, very static page like postoffice.com, right? Your local post office. It may have only one web server. How many times the users are using it? Unless you're talking about something global, like FedEx. Yeah? FedEx is more on the global level, whereas the USPS is only on the country level, national level, right? So now you have the web server 1, you have web server 2, you have web server 3. So web server is nothing but your website pages. Your website pages. Mostly every website page starts with index.html. Okay? And then depending on the load, you may have a load balancer sitting somewhere in between. Yeah? So you may have a load balancer here. That is, every web server is connecting to the same load balancer. Depending on the load balancer, it will connect to one of the other web servers. This guy is load balancer, a separate unit from Cisco. Networking device. So we don't want to put only one server under pressure. So that's why we have the load balancer now. So you have the web server 1, 2, 3, and then during the holiday season, when there is more traffic, you added another web server 4. All these web servers are again same copies of each other. They have exactly same code and dealing with this. Now web servers, we have web server from Microsoft. It's called IIS. We have web server from Unix. Yeah, so web server from Oracle. So Oracle has its own web server called WebLogic, and IBM has its own web server. This is called WebSphere. And then there are a bunch of free versions on other companies. There is another company called Tomcat. Tomcat has its own web server. So depending on what your shop is, some companies are using Microsoft more of a graphical tool, whereas some others are just the text tools. And the people who are managing these are web server admins. Okay. So the web server, the main thing is it has the index.html. Index.html. And then this is basically the load balance. Depending on the load balancer, you have multiple copies of the same web server. Now each of this unit, can you have a computer without an operating system? Can you have a laptop without Windows or Unix or MacBook, iOS? No, right? So similarly, most of these devices is sitting in an operating system. This is also sitting in an operating system. This is also sitting in an operating system. This guy, web server, is also sitting in an operating system. This operating system can be a Unix operating system, or it can be a Windows operating system. If it is Unix, it can use Linux, different flavor, AIX. This is another different flavor of Unix. You can also use HP UX. It can also use Solaris. It can also use some free versions like CentOS. It can also use some other ones, the free ones, Fedora and so on. The most favorite that is going on these days is the Linux. If it is, Windows operating system. Now, the people who are managing these are called either Unix admins, or if it is Windows, doesn't have that much competition. Why? Because Windows is only one graphical OS, otherwise every other is the command-based OS. So here Windows, you have the latest one, there are different versions, so Windows 12, Windows 18, Windows. So what are the Windows versions that we have, we know? The previous one was Windows NT, then we have Windows 2003, then we have Windows 2008, then we have Windows 2012. I don't know what is the latest one, 2018 and so on. I don't know, can someone look into what is the latest Windows Server version?
22.
22 is the latest? Okay, so 2022. The guys who are maintaining the Windows servers are called Windows admins. Okay? Now, if you look at this index.html, 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 index.html is nothing but index.html is nothing but people who are developers. These are the one who writes the code. In different languages. It could be C#, it could be any other language, HTML and other languages, whatever, or Java. Right? So these are the folks who are called developers. They use different language, Visual Basics, I think whatever the newest languages are. So we have the developers, we have the web server admins, we have the network admins, the security admins or the firewall admin. People who are writing the code are the developers. Then these developers write the code and then they have the index.html. And then there are some abc.html, then a3.html. So they have created multiple pages. So people who are testing this code, so somebody will have to test the code. These are called the testers, or what? QA guys, QA folks. These are all testers. So there is a new position now we are calling testers. Who test the code. In general, instead of testing, testers, they are called the QA folks, quality assurance. Do you see that so far? Okay. Now, remember one of so the load balancer has forwarded me to this one, and then now my next hop is the index.html. With the index.html, my code is sent back to the user. So the user who was still waiting, this user is now happy. Why? Because now he has the page open. It says, welcome to chinabank.com. Yeah, it has some menu here. It has its own information here somewhere. It has some other boxes here. Then it has two boxes, login and then the password. And some pretty faces here, some advertisements, windows and so on. The user is happy. Hey, I got the reply back from china.com. The china.com is asking for the login. So login, Scott 1435. Okay. And then the password. That's the user. And then the password. Let's say password is ABC123. And then this guy hits the enter key. Now again, the packets are traveling. It is going to take the shortcut because it knows the IP address. It goes through this. It goes through the firewall. The firewall says, I'm going to send it back to the index.html. The index.html says, how do I verify this username password? I have no information about this username password. What do I do? It will say, I can open up the page, but I don't know if this is a valid login or no. So what I'm going to do is, I'm going to forward this connection to the next layer. The next layer is application server. Now, application server is something where you have the functionality of, think of that as a calculator. A calculator, you can give a value of A and value of B, and then it will give you the result. If my value is 100 for A, the value of B is 50, then the calculator says, once you input these values, I'm going to show you 150. If I do not have those values, I'm worthless. I cannot help you. So, application server is nothing but, think of that as a calculator. Does it hold the value of the user A and user B? Or the login and password? No. So what the application server is going to, and now again, depending on how large of a business or how busy the business is, you could have multiple application servers, and there is a load balancer sitting in between. So now you have another load balancer. Depending on the load, it may balance. So the first time it goes there, second time it may come here. Again, it has the functionality, but it cannot store the values. Now each of this server, the way each of this server has the OS. Yeah? So this server has the OS, this server, this server, this server. Similarly, your application server is also going to have the operating system first. And then it has the application. Now what are some of the applications that are famous? By the way, people who are maintaining these are application admins. Now what are some of the famous applications? SAP is one of the famous, I'm very sure that you guys have heard about. JD Edwards. And then there are a bunch of other, PeopleSoft. They have all these different applications. And then there are a bunch of these. Maybe there is a homegrown application. Homegrown application, so they write their own application. Yeah, some other XYZ company. Whoever is selling their applications. Their application is installed on these guys in here. Now it depends on, if I go with SAP, maybe this is Linux. If I go with some XYZ, maybe it is Windows, we don't know. And you have the similar copies to balance the load. But again, the user is looking for, is this username password is right or wrong? So it goes to the application server. Application server says, I don't know. I don't keep that information. Why are you sending this to me? You're just adding the packet is just growing more. Why? Because now this is my hub. So it will forward this to the next layer. This next layer is the database layer. Now database layer has the operating system. On top of it, it has the version of which database are you using. So now I have operating system and then the database software installed. Okay. People who are maintaining these are the database admins. Okay. Now database, how many different databases that we can have? There is a company called Oracle, which is the industry leader for databases. Oracle has different versions. Oracle started with version 2, then version 3, version 4, version 5, version 6, version 7. Starting around 90s, they have version 7, then version 8. Around 1995, internet came into the picture, so they changed the next version to 8i. Version 8 with the capacity of handling the internet traffic as well. Then version 9, 9i. Okay, 9i came around 1998. Then 10G. G stands for grid. We will talk about this when we move into the databases. Then this is 2003. So this is 98, 95. This is 2003. And 11G, this came out around 2009. Then 12C, this came around 2012. Then 18C, this came in 2018. Now from the G here, I represents the internet. G stands for grid. C stands for cloud. Okay? 18C, 19C came out in 2019. Then 21C came out in 2021. Now they are going with the year-wise version. And then the latest that they have is 23AI. Came out in 2023. And now AI obviously means artificial intelligence. Okay. So the very first version, I believe it came out in 1978. Now what are the other databases that we have? The other databases we have is SAP HANA, Microsoft SQL Server, DB2 from IBM, MySQL, you say open source but now owned by Oracle. You can still use MySQL, but it is owned by Oracle now. And then on top of this, depending on which database that you are selecting, you create your database. To get to the database, remember your connection is keep getting forwarded. It hits something called a listener. Oracle. Every Oracle database server has a listener. This listener runs on 1521 port. This is the guy who keeps the information like password, username, password. Is this right password? Then the user is happy. If the wrong password, the user is not happy. User has to send this again. If the password is everything is correct, and then user says, show me the total transactions I did in last year. Where exactly that data is sitting? Somewhere here. Bank. China Bank DB. All these transactions are coming or recorded in here. And it goes through the listener. Listener is always running on 1521. Now, three things that we are learning in this class. One is the first part for 4 weeks, which is the Linux. We learn Linux because your database is sitting on Linux. So this is one thing that you have to learn. This is the first part. Then the second part is the SQL. This will go for another 5 or 6 weeks. This is called SQL. The reason you have to learn SQL is the communication that is happening between your application server and your database server uses a language called SQL. So we have to learn that. And finally, the third one is the database administration. For the database administration, we are going to focus this part. And this will take about 12 minutes. Do you see how many different positions we have? And this is the last layer. So when you know, I get this a lot. Do you see any future in database administration? Do you see any future for DBAs? Guess what? Everything is dependent on data. If there is no data, nothing exists here. You can have the really good network, but there is no data. What are you going to do? All these other jobs exist because there is data. If there is no data, now there is additional layer of protection to focus, because now the data is it important? Without the data, companies cannot run. Is it important? Yes, the data is extremely important. So there are different ways to protect the data that we will learn in advanced classes. Automatic storage management, data guard, real application clustering, all those different things comes into the later part of the second part of our class, which is the advanced class. But for our next 6 months, this is all the things are we learning? No. We are only learning the first part, the second part, and then the third part. For that, you need to have the basic knowledge of how the packets travel, all this. Now, there are very, networking by itself is about another 6 months course. Do we have to learn all that? No, not really. Our goal is to become the DBAs, not the application admins, not the web servers, not the developers, not the QA folks. And most of this is managed by your project manager. Yeah, if there is a new migration project, a new company's contract that we get, so project managers of the PMs, they pretty much have to work with all these different folks. They are working with web server admins, they are working with security admins, they are working with developers, they are working with testers, they are working with OS admins, they are also working with database admins. And obviously the leadership, they will work with the leadership, the C-level. that make sense? Okay. So now you have the overview as short as possible that I have given in here. Now do you have to know all of these? No, just focus on this and little bit of networking. Whatever that we have learned about the networking, that is sufficient enough for us. We are not going to focus on security, we are not going to focus on load balancers, no Cisco, no SAP, no JD Edwards, nothing, no web servers. Yeah, we are only focusing on our databases. 3 parts. The first part is we have to learn the fundamentals of Linux, not the entire Linux. We don't want to become the Linux admins. We just need to know the basics so that we can support our database. Then we have to learn the language that is used by your application server and your database, because otherwise we cannot troubleshoot it. The third thing is the administration. How many times we should back up the data, how do we export the data, how do we import the data, how we secure the data, how are the roles, grants, permissions, adding the data, creating tables, inserting, updating, deleting, modifying it, altering the parameters. These are what all the administration is. Make sense? All right. That's it for today. Inshallah, I will see you next Saturday. And the very first thing that we are going to look for is straight technical. We are going to start using PuTTY. We are going to connect to our server. Is there any close there?
Yeah.